Hello Shubhodip, good morning. Please join. Please join. I will start. Amarjit, good morning, and Shubho Noborsho too. Good morning, Ankon. Am I audible? Okay. So this is the second class of linear model. First I define, which I already defined, Gauss-Markov model. So again I define this Gauss-Markov model. Gauss-Markov model. Let y1, y2, yn be n independent observations with expectation yi equal to mu y, I from 1 to n, then we can write yi mu y plus ei, where ei is a error associated with yi. Obviously, expectation of ei should be 0 for all I, and since yi's are independent, this implies ei also independent. As yi's are so. We further assume that variance of yi equal to sigma square for all I, that is yi are homoscedastic Now if the means or linear combination of p parameters theta 1, theta 2, theta p, then the model is called linear model. That is expectation y1, y2, yn. I denote this by y curl. So expectation of y curl is equal to mu1, mu2, mu n. This is equal to a11 theta 1 plus a12 theta 2 plus a1 p theta p, a21 theta 1, a22 theta 2, a2p theta p, an1 theta 1, an2 theta 2, anp theta p. I think it is better to write, first you write this thing, that is mu I equal to theta I1, sorry, AI1 theta 1, AI2 theta 2, AIP theta p, I from 1 to n. This imply this. Okay, so this is a11, a12, a1p, a21, a22, a2p, an1, an2, anp, theta 1, theta 2, theta p, so equal to a n cross p theta curl, where a equal to known matrix which is called first you write coefficient matrix, then within bracket known. Okay, now theta curl equal to theta 1, theta 2, theta p, the vector of parameters Here Ai's are given constant, but thetas are unknown. Okay. We are interested in estimating linear function of thetas. The model one is known as linear model or Cauchy-Markov model. This model covers the ANOVA model to regression model three and COVA model, analysis of covariance model. Etc. By a parametric function, we mean a linear function of the parameters that is, if lambda 1, lambda 2, lambda p are a set of linear constant, then pi lambda 1 theta 1, lambda 2 theta 2, lambda p theta p equal to lambda curl prime theta curl is a parametric function. And our objective is to estimate the parametric function and this means estimation of parametric function. This means that is by an estimator of a parametric function we only mean linear function of observations. Next, a parametric function by lambda curl prime theta curl is said to be estimable if there exists a linear function of observation T which equal to C1y1 plus C2y2 Cnyn such that, in short, we write this as C curl prime y curl, where C curl is a C1 C2 Cn prime. So such that expectation of T that equal to C curl prime y curl equal to sum over I from 1 to n Ci yi. This is equal to lambda curl prime theta curl. So this means a parametric function lambda curl prime theta curl is estimable if there exists a linear function of observation such that expectation of this linear function should be equal to pi. Note that a linear model, in a linear model, expectation y curl equal to a theta curl any parametric function lambda prime curl theta curl may not be estimable and it depends on A and lambda curl prime. For example, estimable, and it depends on A and lambda curl prime. Example, let y1, y2, y3 be three homogeneous independent random variables such that expectation of y1 is equal to mu alpha 1 expectation y2 equal to mu alpha 2 expectation y3 equal to mu alpha 3. This is then in matrix notation expectation of y curl is equal to 1 1 1 first column, then 1 0 0 0 1 0 0 0 1, and this is your theta curve mu alpha 1 alpha 2 alpha 3. This is the theta curve and this is your A. Okay, now consider pi, take a pi as alpha 1 plus alpha 2. So this equal to, if your theta 1 is mu, then lambda 1 should be 0, lambda 2 equal to 1, lambda 3 equal to 1, and lambda 4 equal to 0. Okay. Now we check that, the question is to check that whether pi is estimable or not. This is the question. Now consider, so I assume that pi is estimable and expectation of t equal to pi, where t equal to, this is the linear combination of the observation, I already mentioned this. Okay, then expectation of t, this equal to c1 expectation of y1, c2 expectation of y2 plus c3 expectation of y3, and this equal to c1 mu plus alpha 1, c2 mu plus alpha 2 plus c3 mu plus alpha 3. Okay, so then mu equal to c1 plus c2 plus c3 plus c1 alpha 1, c2 alpha 2 plus C3 alpha 3. Now since this equal to alpha 1 plus alpha 2, this implies C1 plus C2 plus C3 equal to 0, C1 equal to 1, C2 equal to 1, C3 equal to 0, which is impossible, because if you take C1, C2, 1, then this does not imply C1 plus C2 plus C3 equal to 0. Hence, T is not, hence pi is not estimable. So, from this example, we see that all parametric functions are not estimable. Okay, and it depends on this matrix A and lambdas. Okay, so next we consider theorem. A parametric function lambda curl prime theta curl is estimable if and only if lambda curl prime belonging to row space of A. I denote script RA by row space of A. Okay. First I prove the only part. That is lambda curl prime theta curl is estimable. This is given. So since lambda curl prime theta curl is estimable, this means there exists a linear function of observation T Ci yi I from 1 to n such that expectation of T equal to lambda curl prime theta curl. This implies expectation C curl prime y curl. I write this summation I from 1 to n Ci yi by C curl prime y curl, where C is a vector, column vector, whose component are C1, C2, Cn. Okay, so this equal to lambda curl prime theta curl. So C curl prime expectation of y curl equal to lambda curl prime theta curl. This implies C curl prime A theta curl equal to lambda curl prime theta curl. So this equal to C curl prime A equal to lambda curl prime. So lambda curl prime is equal to C1, C2, Cn. I denote the row of matrix A by A1 dot, A2 dot, dot dot dot, An dot. That means A I dot ith row of matrix A. So this is equal to this means lambda curl prime is written as linear combination of rows of A. This means lambda curl prime belonging to row space of A, the space generated by the rows of A. So now conversely, that is if part, that is lambda curl prime belonging to row space of A, this is given. So this means we write lambda curl prime is equal to sum over Ci Ai dot I from 1 to n, where Ai dot is a ith row of matrix A. So this equal to lambda curl prime C curl prime A. Now post multiply by theta curl, we get this, and this part is a mean of expectation of y curl. So C curl prime y curl equal to lambda curl prime theta, which is your pi. So pi equal to expectation C curl prime y curl. Hence C curl prime y curl is linear unbiased estimator of pi. Hence pi is estimable. Now we see that lambda curl prime, we already see this thing is estimable if and only if lambda curl prime belonging to row space of A. So this means if you add one row with A, that is the rank of this augmented matrix equal to rank of A. So if you want to check whether the parametric function is estimable or not, for this you just use this tool instead of applying using the detailed calculation, which I already shown in my previous example. So now I consider this example that is expectation of y1 equal to mu plus alpha 1, expectation y2 equal to mu plus alpha 2, and expectation y3 equal to mu plus alpha 3, and our interest is whether alpha 1 plus alpha 2 is estimable or not. Estimable or not. So I want to check this thing. So see that your A matrix here is okay, and the lambda is so now this is an augmented matrix. We add this row with matrix A. So you see that it is very easy to see that just seeing the position of zeros, the rank of this matrix is equal to 4. However, rank of A equal to 3. Hence, rank of A lambda curl prime not equal to rank of A. Therefore, alpha 1 alpha 2 is not estimable. Suppose you want to check that this is your homework. Suppose now we try to find the condition for a parametric function. This generally lambda 1 whether lambda 1 alpha 1, lambda 2 alpha 2, lambda 3 alpha 3, find the condition of such that lambda 1 alpha 1 plus lambda 2 alpha 2 plus lambda 3 alpha 3 is estimable. Okay, so for this problem you just now your augmented matrix is this. So if you apply row operation, then you get you see that these three vectors are independent. Now just applying operations, row operation, R2 minus R1, R2 this you get 1 0 1 minus 1 0 1 0 0, then R3 minus R1, this is R2 minus R1. Okay, now R3 minus R1, so this 0 minus 1 0 1. So this is 0. Now lambda 1, lambda 2, lambda 3, make it echelon form, multiplying minus 1 by R2 then you get 1 1 0 0 1 1 minus 1 0 0 minus 1 0 1 0 lambda 1 lambda 2 lambda 3. Okay, now R3 R2 plus R3, this gives 1 0 0 0 1 1 0 0 minus 1 0, sorry, this is minus 1 0 0 1 lambda 1 lambda 2 lambda 3. Now R3 minus 1 R3 1 1 0 0 0 1 minus 1 0 0 0 1 minus 1 0 lambda 1. So R4 minus lambda 1 R2, then we get 0 lambda 2 plus lambda 1, then this is lambda 3. Okay, next lambda 4 minus lambda 3 1 1 0 0 0 1 minus 1 0 0 0 1 minus 1 0 0, sorry, this is lambda 2 plus lambda 3. So R4 minus lambda 2 plus lambda 3 into R3. Okay, so then this is 0 and this is lambda 1 lambda 2 plus lambda 3. So now you see that the rank of this matrix equal to 3 if and only if lambda 1 lambda 2 plus lambda 3 0. Hence this parametric function lambda 1 alpha 1 plus lambda 2 alpha 2 plus lambda 3 alpha 3 is estimable if and only if lambda 1 plus lambda 2 plus lambda 3 equal to 0. This means this all are estimable, lambda 1 lambda 3 lambda 1 lambda 4 alpha 1 minus alpha 2 alpha 1 alpha 3 alpha 1 alpha minus alpha 4 all are estimable. or else, because you see that in every cases lambda 1 plus lambda 2 plus lambda 3 equal to 0. So lambda 1 alpha 1 plus lambda 2 plus alpha 2 plus lambda 3 plus alpha 3 is estimable for this model if and only if lambda 1 plus lambda 2 plus lambda 3 equal to 0. Okay, so this is the procedure. So any question, please tell me. Have you any question? Please tell me. শুভদীপ, অঙ্কন, অমর্ত্য, শাশ্বত, সমরজিৎ, have you any doubt? Please tell me. Okay. Error function. A linear function e curl prime y curl u1 y1 plus, okay, thank you Somujit. Where is our constant. A linear function, this is called Partho, good morning. So this linear function is called error function. If expectation of e curl prime y curl, this is equal to 0. That is, e curl prime y curl is error function if it is an linear unbiased estimator of 0. So a linear unbiased estimator is an error function if and only if e curl belonging to orthocomplement column space of A. This is a ortho complement of column space of A. So this is our claim. Okay, so I consider this as a theorem. Proof. By definition, E curl prime y curl is a error function. This should be 0. This means zero. This means 0 curl. Zero, where jth column of A, and this j from 1 to p. Hence, since E curl is orthogonal to columns of A, this means E curl is orthogonal to column space of A. This means E curl belonging to orthocomplement of column space of A. Okay. Next definition, estimation space. The column space of A is called the estimation space. Suppose rank of A whose order n cross p equal to r less than equal to p, then dimension of column space of A should be R, and dimension of error space, this is equal to n minus R. And we already know from the linear algebra classes, that is, column space of A is a direct sum of column space of orthocomplement space of column space of A. That means this is a estimation space and this is error space. So this gives VRN. Now, so we have so many linear unbiased estimator of pi, and we select the unbiased linear unbiased estimator which gives minimum variance. This is one of the criteria of selecting good estimator, and this is called best linear unbiased estimator. We know this thing. So first we define best linear unbiased estimator blue. Let lambda curl prime theta curl be an estimable parametric function. Then there exists a linear function, since it is estimable, C curl prime y curl, such that expectation of C curl prime y curl equal to lambda curl prime theta curl for all theta. But we know that linear unbiased estimator are not unique. So we have searched for the best one, and linear unbiased estimator C curl prime y curl of lambda curl prime theta curl is said to be best if variance of C curl prime y curl less than equal to variance of D curl prime y curl, where D curl prime y curl is any linear unbiased estimator of lambda curl prime theta curl. Then this C curl prime y curl is called the best linear unbiased estimator blue of lambda curl prime theta curl. Now consider a theorem. For an estimable linear parametric function, lambda curl prime theta curl, there exists a vector C curl such that there exists a vector C curl in cross 1. This belongs to estimation space, that is column space of A, such that C curl prime y curl is best linear unbiased estimator for lambda curl prime theta curl. True. As lambda curl prime theta curl is estimable there exists a linear function L curl prime y curl such that expectation L curl prime y curl should be lambda curl prime theta curl for all theta curl. Now this L curl belonging to Rn, agree? Because order of y is n cross 1, so L curl should be belonging to Rn. So as we know, this Rn is nothing but a direct sum of column space of A and ortho complement space of column space of A. Then this means we know from the projection L curl is uniquely written as L curl equal to C curl plus E curl, where C curl belonging to column space of A and E curl belonging to ortho complement space of column space of A, that is error space. Okay. Therefore, or error space. Therefore, lambda curl prime theta curl equal to expectation L curl prime y curl equal to expectation L curl is not, we write this as a C curl plus E curl prime y curl. So this equal to C curl prime y curl plus expectation E curl prime y curl. Okay. So E curl belonging to ortho complement space of column space of A, this means E curl prime y curl is a error function. So this means expectation C curl prime y curl equal to 0. So this equal to C curl prime y curl. Hence C curl prime y curl is another linear unbiased estimator of lambda curl prime theta curl. Now variance of L curl prime y curl, this is equal to variance of C curl prime y curl E curl prime y curl. This is equal to variance of C curl prime y curl plus variance of E curl prime y curl, and the covariance term is 0 because C curl is orthogonal to E curl, because C belonging to column space of A and E curl belonging to ortho complement space of column space of A. Okay. So this should be greater than equal to variance of C curl y curl. Since variance of E curl y curl greater than equal to 0, This means C curl Y curl is best linear unbiased estimator for lambda curl prime theta curl. L curl prime Y curl is any unbiased estimator, linear unbiased estimator of lambda curl theta curl. From L curl we can decompose L curl uniquely by two vectors. One vector is belonging to column space of A and another is orthocomplement space of column space of A. Because column space of A and orthocomplement space of column space of A are direct sum, and this gives Rm. Okay, so from this we see that variance of any linear unbiased estimator always greater than equal to variance of C curl prime Y curl. This means C curl prime Y curl is not only a linear unbiased estimator, it is best in sense its variance is minimum. Okay. So here we observe that C curl prime Y curl is blue for lambda curl prime theta curl if and only if C curl belonging to column space of A. So that means we write C curl as A Q curl, where Q curl belonging to Rp. P is a number of columns of matrix A. Okay. Now since C curl Y curl that is equal to Q curl prime A prime Y curl is blue for lambda curl prime theta curl, this implies expectation Q curl prime A prime Y curl this equal to lambda curl prime theta curl. So this equal to Q curl prime A theta curl equal to lambda prime theta curl. So A prime A lambda curl prime. So this equal to A prime A Q curl lambda curl. So from this equation we know lambda curl, we know A. So from this equation, this is a system of non-homogeneous equation. From this equation we get Q curl. The now question is whether this Q curl is this solution is or this equation is solvable or not. Answer is yes. Why? Equation is solvable because rank of A prime A lambda curl equal to rank of A prime A. This is your homework. Please prove it. my claim is this equation is solvable, and for proving this we need to show rank of A prime A equal rank of A augmented matrix. That means if you augment one column by a vector lambda curl, then this rank of augmented matrix equal to rank of A prime A. Okay, so you prove this thing. If you prove this thing, that means this equation is solvable. This is your homework. Okay. Now next question is, yes, the equation is solvable. Is the solution unique? Because it is necessary. Otherwise you cannot say that this is a blue. So we know a general solution for non-homogeneous equation, say Q curl, it should be Q naught curl, which is a particular solution plus xi curl. This is a solution of the solution xi curl belonging to orthocomplement space of A prime A. That is null space or error space. Okay. So I assume there exist two solutions. Assume there exist two solutions of equation, say it is 1, that is Q curl hat and Q curl double hat. Clear? So this means Q curl hat equal to Q naught plus xi 1, such that xi 1 belonging to orthocomplement space. This means xi 1 prime A should be 0, and Q curl double hat, this is equal to Q naught plus xi 2 curl, such that xi 2 curl prime A equal to 0. Therefore, Q curl hat prime A prime y, this is equal to Q naught curl plus xi 1 prime A prime y, this is equal to Q naught curl prime A prime y curl plus xi 1 curl prime A prime y curl. Okay. Similarly, Q double hat prime A prime y, we write this as Q naught curl prime A prime y, xi 2 curl prime A prime y. Since xi curl is orthogonal to column space of A prime A, this again column row space of A prime A. and this row space of A prime A is nothing but a column space of A prime, and this means xi curl is also orthogonal to column space of A prime. Or you can simply say that this is not required. I think columns xi curl is orthogonal to column space of A prime A. This automatically implies this is orthogonal to column space of A prime. You can verify this thing. It is obvious. Okay, so this means xi1 curl prime A prime y curl 0 and xi2 curl prime A prime y curl, this is also 0. So hence this q curl hat prime A prime y curl equal to q naught curl prime A prime y curl, because xi1 prime A prime y is 0. So similarly q double hat prime A prime y curl, because this is again xi2 prime A prime y equal to 0, this means q double hat prime A prime y is equal to q naught prime A prime y. Therefore this solution is unique. The solution is unique. Okay, so please tell me if you have any doubt. Take a 5 minutes break and tell me. I will be back within 5 minutes. Please tell me if you have any doubt. In meanwhile, please check and verify and tell me if you have any doubt. I will be back within 5 minutes. Okay, so have you any doubt? Please tell me. Can I rub this portion? Yes. Please join. Please join. Okay. Now we consider an example. Let y1 equal to 2, y2 equal to 3, y3 equal to 4 be 3 observations. From the linear model, expectation y1 equal to theta 1 plus theta 2, expectation y2 equal to theta 1, y3 equal to 2 theta 1 plus theta 2. The question is, find total number of independent estimable parametric function solution. We write this model as so this is the matrix A, and this is theta curve. Now this A equal to make it echelon form for finding rank of a matrix, and this rank gives total number of independent estimable parametric function. Okay, so for this reason we first find the rank of a matrix. So R2 minus R1, then R3 minus 2R1, please tell me if there is any wrong or mistake. Please tell me. So see that rank of matrix A. This is the process, but thing is that here the matrix A is very simple. We can easily see that these two rows are independent. Just see the position of zeros. Okay. Next, you see that if you add these two rows, you get third row. Hence, rank of A is 2. You automatically get this rank. You get the rank of matrix A. But in generally, A is not so simple as it is. So for this reason, we generally, for finding rank, we can make the form of a matrix A to a echelon form. For making echelon form, we use generally row operation, and this is the process. Okay. So in general, if your matrix A is not so simple, in that case, for finding rank of A, you use this row operation. Okay. Otherwise, if you see this easily, you can find. You can, from the observation, you can see the rank. Then you can write this thing, just arguing, just give the argument why you take 2. Here it is. You see that first two rows are independent, or otherwise you can see the column. It is another way. You can see the columns. If you see just the positions of zeros, then you can easily see that these two columns are independent. Hence rank of A equal to 2. Okay. So since rank of A equal to 2, the total number of the answer of this question, the total number of independent estimable parametric function here is 2. Okay. Have you any question? Please tell me. Next queries is verify whether theta 1 plus 2 theta 2. Okay, thank you, Shomujit. Is estimable or not? So for this, we already know the method. Just this is your A matrix, and you augment your this 1 2, where lambda curl prime is equal to 1 2. Okay, I just augment this row, and now see that the rank of this matrix is again 2. Hence this is estimable. Next question. Find the blue. Find blue of theta 1 minus theta 2 if it is estimable. So you know the tool. First you check whether it is estimable or not. So it is rank of this is 2. Hence is estimable. Now find do of this. So here lambda curl equal to 1 minus 1 prime, and a prime a is equal to 4. This is your A matrix 1 1 1 0 2 1. So first entry is 4, second is 1 0 2, that means 3, and this is 2. Okay, so now you need to find Q curl, where this equal to lambda curl. We know from the previous result. And then so please tell me the solution of Q1 Q2. Let's solve these two equations and tell me the solution of Q1 Q2. Please tell me. Somojit, please tell me the solution. Q1 Q2. Can you finish this thing? If so, please just write the solution in comment section. I am waiting. Onkon. Amartya, please tell me. Shashwato. Somojit. Okay, just a second. Now it is complete. Tell me. Okay, Q1 is minus 5 and Q2 is 7. Okay, so Somojit Shashwato, say minus 5 and this is 7. Just I check this thing. minus 5, this means is minus 20, and this is 21. Okay, it is right. Then this is minus 15 plus 14, this is again also true. Good, thank you. So Q1 is minus 5 and Q2 is 7. Okay, okay Shohini, thank you. So now according to the previous result, now the blue of theta 1 minus theta 2 is Q curl prime, A prime, Y curl, and Q curl prime is our minus 5, 7. Okay, and A prime is 1, 1, 1, 0, 2, 1, and then Y1, Y2, Y3. So this is minus 5 minus 7, this gives you 2, then this is minus 5 minus 10, 7, so this is 3, Y1, Y2, Y3, so this is equal to 2y1 minus 5y2 minus 3y3. So this is the blue best linear unbiased estimator of, hence 2y1, 5y2, 3y3 is best linear unbiased estimator, mind it, I write estimator, of lambda 1 minus theta 1 minus theta 2. Okay, and if you interested in estimate, so best linear unbiased estimate of theta 1 minus theta 2, just put the value of y1, y2, y3 which is given in your question. That is, I think y1 is 2, so this 2 into 2, 5 into 3 minus 3 into 4. So this is 4 minus 15 minus 12, that means minus 23. So minus 23 is best linear estimate, mind it. Minus 23 is a best linear unbiased estimate, best linear unbiased estimate of theta 1 minus theta 2, and when the when in the question there is a best linear unbiased estimator, then this is 2y1 minus 5y2 minus 3y3, that is 2y1 minus 5y2 minus 3y3 is best linear unbiased estimator of theta 1 minus theta 3, minus 3 is best linear unbiased estimate of theta 1 minus theta 2. Okay, so this is the method to get best linear unbiased estimator. So if you have any queries, please tell me. Next theorem. Let lambda 1 curl prime theta curl, lambda 2 curl prime theta curl, lambda k curl prime theta curl be k estimable parametric function, then their linear combination also a estimable parametric function. proof is very simple. Let Ti be linear unbiased estimator of lambda I curl prime theta curl I from 1 to k, then expectation sum over I from 1 to k pi ti is equal to, you can check this thing, pi lambda I curl prime theta curl for all theta curl. So sum over I from 1 to k pi ti is linear unbiased estimator of summation I from 1 to k pi lambda I curl prime theta curl. So this means if the parametric functions are estimable, this you get a, then this means if the k parametric function linear function is estimable, parametric function is estimable, then their linear parametric function is also estimable, and you can get this thing, just take a linear combination of their estimators, that is pi ti I from 1 to k, where ti is a linear unbiased estimator of lambda I curl from theta curl. So you can take just a linear combination of this estimator TIs, then you see that this gives sum over I from 1 to k pi lambda I curl prime theta curl for all theta curl. So this imply their linear function also a estimable linear parametric function. Okay. Next, and this is the last theorem for today class, that is Gauss-Markov theorem. We have obtained the blue of estimable parametric function lambda curl prime theta curl as q curl prime a prime y curl. We get this, we know this thing, where this q curl is given by a prime a q curl lambda curl. Okay. However, using any solution theta curl hat of the normal equation the blue can also be obtained. This method is due to Gauss-Markov. This method is due to Gauss-Markov. The statement of this theorem is let lambda curl prime theta curl be an estimable parametric function, then lambda curl prime theta curl hat is the best linear unbiased estimator blue of lambda curl prime theta curl, where theta curl hat is any solution of the normal equation. That is A prime A theta A prime y curl. Okay, this is the normal equation because our model is and we already discussed, we get the normal equation from using least square technique. And proof. We know that the blue of the estimable parametric function lambda curl prime theta curl is given by q curl prime A prime y curl, where we know this thing. Q curl satisfies A prime A Q curl equal to lambda curl. Therefore, the blue of lambda curl prime theta curl is Q curl prime A prime y curl. This is equal to Q curl A prime y curl means A theta curl hat, A theta curl hat. Okay, so and this is obtained from normal equation. This is the normal equation, a prime a theta curl hat equal to a prime a. This is from normal equation. And this is equal to lambda curl prime theta curl hat, since a prime a q curl equal to lambda curl, where is called the least square estimator of lambda curl prime theta curl. So this means if lambda curl prime theta curl is estimable, first you need to check this thing whether lambda curl prime theta curl is estimable or not. If lambda curl prime theta curl is estimable, then this lambda curl prime theta curl hat gives best linear unbiased estimator of lambda curl prime theta curl, where this theta curl hat is a solution of this normal equation. Again I repeat this thing. First you need to check lambda curl prime theta curl is estimable or not. If lambda curl prime theta curl is estimable, if this lambda curl prime theta curl is estimable, then lambda curl prime theta curl hat gives best linear unbiased estimator of lambda curl prime theta curl, where this theta curl hat is a solution of the normal equation. So this is the statement, or this is the use of Gauss-Markov theorem. Actually, if you using this theorem, you just need to find the solution of theta curl hat, and use this solution, and you know the lambda curl. So using this solution, you can easily get the best linear unbiased estimator of lambda curl prime theta curl. So this all about Gauss-Markov theorem. Next day we will take some examples and then check some other estimability conditions of parametric functions, and if the time is permit, then we will discuss and we also discuss variance covariance matrix, and if time is permit, then we will discuss sum of squares and corresponding degrees of freedom. Okay, so have you any question? Please tell me. I am waiting for you for 5 minutes. After that I will end the stream. So thank you. So please tell me, have you any question or queries? I am waiting for you. So are you enjoying the class? Please tell me. Thank you, Shashwato. So we will meet Sunday, next Sunday, same time, 10 p.m. please join Sunday for this class. Please, if you have any question, Shashwat say no, sir. So showing no doubt, sir, and thank you. Okay, so showing thank you. So I want to end the stream. Okay, thank you everybody.